Good evening. I'm filming this in my evening, calculus students. So we want to evaluate both this and this. So what I'm doing here is I'm presenting the cancellation laws for integrals and derivatives, more specifically indefinite integrals and derivatives. So there's not much calculations that we will do because finding the integral of tangent of square root of x is actually quite tedious. And taking the derivative to integrate it again, there's actually not much point. So this is a conceptual question. There's not much calculation to do. So let's begin with this number, okay? So what we're gonna do is we're gonna give a name to the antiderivative of tangent of square root of x. So okay, let f of x be equal to the tangent of square root of x, and capital F of x to be so let's actually rewrite this. Let f of x be an antiderivative of of f of x, which is again like the tangent of square root of x. Okay. Then what do we know? Then we know that the integral of tangent, actually let's actually give let's give ourselves a little bit of space. So we know that the integral of tangent of square root of x dx is going to be equal to capital F of x plus c. Now what we're going to do to find the first number is to differentiate both sides with respect to x. So differentiate both sides with respect to x. So what are we going to get? Well, taking the derivative of this thing. So let's put the blue in the green, right? The tangent of square root of x dx. Well, that will be equal to the derivative of this side, like the capital F of x plus c. So now what we need to do is we just need to simplify this. Well, the derivative of big F of x is going to be capital F prime of x. Let's put it this way. And then we have the derivative of a constant, which, remember, is simply 0. Okay? So now the derivative of f prime of x is actually f of x. And this is because of this, right? So let's actually underline it. Since f of x is an antiderivative of f, like we are getting this. And the derivative of c is 0, so I'm being lousy here, but I'll write the 0. But in the end, okay, so what you get is the tangent of square root of x plus nothing, right? This is actually the answer. So what I want you to realize is that in this scenario, we got exactly this. Now let's have a look at the other scenario, the one that we have right here. Okay? So in this case, we have to play with, so we know that d over dx of tangent of square root of x, okay, is gonna like tangent square root of x is gonna be equal to f prime of x, okay, where like f is a tangent of square root of x. So f prime is the derivative of it. Okay? And this means that f of x is an antiderivative of of d over dx of tangent of square root of x. So all right, let's so what can we deduce from there? Well, very simple. If we take now the integral of this, so if we take the integral of like d over dx of tangent of square root of x, and then dx, I'm going to put the dx in green, okay? The integral is going to be the collection of all the antiderivatives. So in other words, now I'm going to color code in black, I think. Yeah, black is a good color. So we deduce that f is an antiderivative, okay? So we can say here that the collection of all the antiderivatives will be of the form f of x plus c, where c, remember, it's the constant of integration. So now what is f of x? F of x is the tangent itself, right? So let's write it down. We have the tangent of square root of x plus c. So this is the answer to the second question, all right? So you have, so what I want you to note is that you don't exactly have this. You have like this plus c. All right, so this is the end of this example, but what I want to tell you is that the results that we found here and here are actually general to any function. So if you are trying to find something of this form with some function over here, you'll get back the same function, tangent of square root of x, like the same function as what's here. However, if you do the reverse, if you first take the derivative and then integrate the result, then you will pop a plus c at the very end, right? You're going to have the same antiderivative, like, well, you're going to have the same thing, but then you're going to add the plus c. So that's how the cancellation laws are working between derivatives and integrals. I hope this was helpful. See you either in the next video or in class.